All right, so in this unit, we're going to be looking at ionic, covalent, and metallic bonding. And you'll learn how to write the name and formulas of ionic and covalent bonds, and then really understand what the difference between these bondings are and how that affects how the substances will react.
All right, so let's first look at ionic bonding. So what's happening here, notice sodium has 1 valence electron, chlorine has 7. And so as we had noted when we were talking about charge, it is very likely that sodium will give its electron to chlorine. That way sodium will have 8 valence electrons in its second energy level, and chlorine will have 8 valence electrons in its third energy level. So let's see if that happens. Okay, so sodium is going to give its electron to chlorine. Okay. And so now sodium has a +1 charge and chlorine has a -1 charge, and they are stable because they both have octets. Now, the reason why I talked about periodic trends, specifically talking about electron affinity, the reason why chlorine does such a good job of taking that electron from sodium and sodium does such a good job of giving it up is because sodium has a very low electron affinity because it's farther to the left on the periodic table, and chlorine's very good at keeping that electron because it's further to the right, so it has a higher electron affinity. So sodium gives up its electron because it has a low electron affinity, chlorine accepts it. And now because we've got a positive and a negative charge, those ions are going to be attracted to each other because opposite charges attract. And that attraction is an ionic bond. Okay, so let's fill in the notes for this. All right, so as we noted, ionic bonding occurs between a metal and a nonmetal. The metal is going to, as we saw, lose electrons. So it loses electrons. It can lose 1, 2, 3 electrons, 4 sometimes, while the nonmetal gains the electron. And remember, this is because the metal has a lower electron affinity, so it is more willing to give up electrons, while the nonmetal has a larger or a higher electron affinity. Okay, so that's ionic bonding. Let's go back at our simulation and look at covalent bonding. So remember, covalent bonding occurs between two nonmetals, while ionic occurred between a metal and a nonmetal. Now for covalent bonding, there isn't this huge difference in electron affinities. One of the atoms is not going to donate electrons to another. However, they still want to have 8 valence electrons. So how do they achieve that if one can't give electrons to another? Well, what they're going to do is they are actually going to share. So notice carbon has 4 valence electrons, while oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So here's what they do. It's pretty ingenious. They are going to share electrons. So now carbon has shared 2 of its electrons with oxygen, and oxygen has shared 2 of its electrons with carbon. And so now carbon has 1, 2, 3, 4, 5, 6. And we're not quite done because it's going to share with the other oxygen. And then oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is perfectly content by sharing electrons. Now this sharing is going to happen on the other side. So now carbon has a total of 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it has that full octet and it is stable. While the second oxygen has 1, 2, 3, 4, 5, 6, 7, 8, and it is content. So the reason why it's important to understand electron affinity is because there isn't that huge difference in electron affinities between two nonmetals. Instead of giving up electrons, what's going to happen in covalent bonding is they're actually going to share them. And that attraction, those shared electrons, form what is a covalent bond. All right, let's fill in the notes for covalent bonding now. All right, so as we noted, covalent bonding occurs between a nonmetal and another nonmetal. So it's really important to remember what makes something a metal versus a nonmetal, as you can see based on ionic and covalent bonding. So as a quick review, we've got this lovely periodic table here. Remember, if you're to the left-hand side of the staircase, you are a metal unless you are hydrogen. Everything to the right of that staircase is a nonmetal. Okay? And because they have very similar electron affinities, one atom is not going to steal an electron from another one, right? The nonmetal is not going to steal it from another nonmetal because they have very similar electron affinities, as we saw. So the atoms, therefore, are going to share electrons. Okay. For metallic bonding, it occurs between two metals. Okay? And so here I've got copper and zinc. Now, because metals have such a low electron affinity, what's going to happen, instead of sharing or donating electrons one to another, one giving up, one accepting, like in ionic bonding, what's actually going to happen is all of the atoms are actually going to kind of get rid of their electrons. Okay? And so what happens, it's really cool, is these electrons are just going to be moving freely between all the different atoms like this, because the atoms themselves were not strongly attracting the electrons. And what this is a sea of electrons. So basically the electrons are just going to constantly be moving around all of the atoms. And this is why metals, or metallic alloys, which is just a combination of two different metals, it's a mixture of metals, they are really good conductors of electricity because their electrons are not held together in a bond, like in covalent bonding, or their electrons are not donated from one atom to another like they are in ionic bonding. Instead, they're free to move around, which is why they're really good at conducting electricity. Okay, so now for metallic bonding. Metallic bonding occurs between a metal and another metal. It can be two atoms of the same metal, or it can be two different metals, like copper and zinc. Okay. Electrons create what we call a sea of mobile electrons. Okay, and those, as you guys saw, those electrons are moving freely around those metal atoms. And the reason why is because all of those metals have very low electron affinities. So they're willing to give up their electrons, and what's most stable is for those electrons just to be moving freely around all of those different atoms. And so this sea of mobile electrons actually explains why metals are good conductors of electricity. Okay. Let's now look at identifying the type of bonding. So we either want to identify it as ionic, covalent, or metallic. All right, so aluminum and oxygen. Aluminum is to the left-hand side of that staircase, so that makes it a metal. Oxygen is to the right of that staircase. It is a nonmetal. It will therefore experience ionic bonding. Okay? Oxygen is to the right of the staircase. It is a nonmetal. Fluorine is also a nonmetal. So when you have two nonmetals, they're going to share electrons. They're going to form covalent bonds. If I have two copper atoms, they're both metals, obviously. And then in that case, I have metallic bonding. Remember, it can be two different metals or two of the same metal. That's totally fine. Carbon is to the right of the staircase, so it is a nonmetal. Sulfur is also a nonmetal. And so if carbon and sulfur were to form a bond, it would be a covalent bond, and they would share their electrons.